All right, why don't we get started here? So my name's Derek Yu. I'm the CEO of a company called PureStake, but the main project we work on is called Moonbeam. And wanted to talk to you today about not just about Moonbeam, but about more broadly cross-chain scenarios, right? Cross-chain connected scenarios, and what I think are actually some quite interesting developments that are happening right now around teams that are building new kinds of applications that cut across different blockchains. And so that'll really be the subject of the talk today. And so I would start a little bit with some background. The question is, why is it that we're moving into this multi-chain world? When we started Moonbeam as a project back in 2019, we had this idea that we were going to move into an environment with more blockchains, make many more blockchains. And that's started to happen, right? Since 2019, there's a lot of new blockchains, Moonbeam being one of them. But I think we're starting to become clear why it is that we're moving into this multi-chain world, right? There's just increasing demand for block space that is driving the creation of new chains and new development frameworks that are coming around, right? So development frameworks like the Cosmos SDK or Substrate make it a lot easier to build your own blockchain. And so you have this opportunity to specialize. And I just see this trend continuing, right? So I kind of liken it to, I often think about the history of compute. And in the early days of compute, there was very few computers, right? And there were people even around at the, way back then saying things like, there's only going to be a small number of computers, they're so expensive, they're so difficult to manage. There's only going to be a few of them and people are going to share them. Well, obviously, that's not how things turned out, right? When you have something useful that gets created, it tends to specialize over time. There's multiple different niches that the technology will move into. And I think it'll be something similar with blockchains, right? Albeit with a kind of a consolidation around certain tech stacks or operating systems. The EVM being one, which we'll talk about. We've made a big bet on the EVM. Substrate being one, Cosmos SDK being another one. There's a few kind of concentration areas that we're going to see as this plays out. But let me first give a little context on Polkadot, which is kind of the system that we're part of, or the network that we're part of, and we're using a lot of the technologies that come from the Polkadot ecosystem to build Moonbeam. And given this kind of vision that there's going to be many blockchains, the first question that came to our minds was, well, how are these chains going to communicate with each other? And this is something that led us down the path towards Polkadot even back in 2019 when we started. And so I would summarize the core idea of Polkadot as consisting of two main principles. One is that you can have specialized chains. So you can create your own blockchain using Substrate, the development framework. You can specialize that chain to be good at a particular thing. And then the idea of Polkadot is that you can basically connect these different specialized blockchains together so that they can talk to each other, so they can exchange information, so that they can use services from each other. And so those two ideas together are really the core ideas of Polkadot, and I still find them as attractive today as I did back in 2019 when I first learned about them, that you have this whole is greater than the sum of its parts concept, right? Where you can have these many specialized chains that are all working in concert together to deliver some higher level effect. And so that's kind of the environment that we're part of. And so to talk about what Moonbeam is, so Moonbeam is one of the kind of member chains of Polkadot. It's called a parachain. But the idea of Moonbeam is to be a smart contract platform that specializes in cross-chain use cases. So that is really our focus and specialty. We have some unique ways of addressing those kinds of scenarios by being part of Polkadot and leveraging their XCM technology, which we'll talk about a little bit later in the talk. But the idea is that we use this concept of connected contracts. The idea is that a smart contract on Moonbeam can be used to reach any user, any asset, or any service, regardless of what blockchain it's on. And we're using some pretty interesting technology to accomplish that, XCM being one, but also integrations with a number of different cross-chain messaging systems, which have just come to market this year. And so I do think that this is an area that I'm quite excited about, because I think we're at the beginning of let's call it a big shift that's going to happen in the next 12 to 24 months, where developers are going to start using these cross-chain messaging technologies to deliver apps that really do different things than kind of the apps that are around today, that work in a different way. So when we're talking about connected contracts and this ability to create smart contracts on Moonbeam that can reach out across to different blockchains and access services, access assets, there's really three supporting ideas in Moonbeam that help make that happen. So one of them is this cross-chain messaging. And here I drill in a little bit and say that within cross-chain messaging, you have different approaches that are being tried out now. So the market is still early. A lot of these systems have just been shipped, including XCM. So Polkadot's XCM went live about 2 months ago. We already have a number of different use cases already live, like on Moonbeam, and many more that are kind of in development right now. But there also has been this rise of these, what I'd call these overlay networks. So different kinds of networks that will allow developers to send messages across blockchains, even across different consensus systems. And so a couple examples of ones that we've been working with early on are the team at Axelar and Nomad, two partners of ours, where there's already significant development activity happening by teams that are leveraging the cross-chain messaging from these different providers. So there's this cross-chain messaging element, and I will go through a number of examples to help illustrate like the kinds of things we're seeing. But that alone doesn't get you what you need. So on Moonbeam, we're also providing a full development environment. We've done a full implementation of the Ethereum tech stack in Substrate. So Substrate is the Rust-based development framework that you use to develop things, to develop blockchains, like in either standalone blockchains or blockchains that are going to be part of the Polkadot network. So we've done a full Ethereum implementation, EVM, Web3 RPCs, the whole thing, and also surrounded that with all of the tools that an Ethereum developer expects and needs. So those are things like an Etherscan deployment. We just had a Chainlink integration go live, and there's a long list of integrations of different tools that, if you're coming particularly from an Ethereum environment, that you expect to be there to build. And the third pillar is around being able to offer advanced functionality that comes from this being part of Polkadot and being based on Substrate. So that includes features like on Moonbeam itself. We have a full on-chain governance system. We use that for forkless upgrades. We have a number of different kind of local advanced features that have been created and exposed into the EVM on Moonbeam. But it also means access to all of the other specialized functions that other parachains are providing on Polkadot. So that includes things like Oracle services, like identity services, and there's a number of other parachains that are under development that would offer different kinds of services that can be made available to the EVM environment on Moonbeam. And probably the thing I'm most excited about there is that there is an upcoming feature around called parathreads, which allows developers to express logic in Substrate without all of the kind of hoops that you normally have to jump through to launch a parachain. So developers will be able to extend Solidity-based smart contract functionality with blockchain level Substrate functionality and link it to their smart contracts on Moonbeam. So again, these are all kind of supporting pillars of this idea of connected contracts that we are heavily focused on these days. And so I'm going to walk through some examples, but before I walk through the examples, I want to talk a little bit about what the current state is of multi-chain deployments, so that it becomes clear why the connected contracts approach is better or solves some of the challenges that are present with the existing approaches. And so I think it's the case, particularly if you look in DeFi right now, that almost every project needs some form of multi-chain strategy. Right? The days are kind of somewhat gone of just saying, hey, I'm going to just choose one chain and only deploy to that chain. You still find it from time to time, and the strategy there would be, okay, I'm only going to have a mainnet deployment. I expect everyone to bridge into that chain to just reach my smart contracts. I would say that's largely given way to the idea of what I call a multi-instance deployment. So a multi-instance deployment is a deployment where you have basically, often started on mainnet, right? You have some set of contracts there. You take those contracts and you just deploy copies of them to each target chain you want to deploy to. So you may have, let's say, a lending and borrowing protocol. It's deployed on mainnet, and they say, you know what? I'm going to make a copy of that deployment on Avalanche. I'm going to make a copy of that deployment on Polygon. And so you have these, new instances of the protocol on, potentially many chains, right? I mean, there's some protocols that are deploying, let's say, up to 12, 13, 14, 15 different chains, right? Especially EVM-compatible chains. And so that's I would say, kind of the state of the art right now for a strategy to get at assets and users that are being spread now across many chains, right? It's like this multi-instance approach. Let's bring the protocol to the users by making copies of it. So the problem with this approach, or the challenge, is I would summarize it as one of fragmentation. And so what do I mean by fragmentation? What I mean is these deployments are all like independent of one another. I mean, they share the same branding, so don't get me wrong. You go to like one website sometimes to access them. You'll have a selector, right, to select like what chain to go to. But the actual smart contracts themselves are isolated. You know, the deployment on Polygon knows nothing about the deployment on Avalanche, knows nothing about the deployment on mainnet, right? These are all isolated like deployments. And so what that means is you get this fragmentation effect, right? So your users, for one, get fragmented, but the features get fragmented. So often it's the case that the mainnet deployment is like the first-class citizen. It has the full feature set. And then there's some subset of the features that are getting deployed on the target chains, because sometimes there's like clashing or overlapping, you know, there's questions that come up, like, and we'll get to some of these later around, for example, governance, right? So what does it mean to have governance happening on two chains at once? Well, no, let's just do that part on mainnet, and then the satellite deployment only has the minimal feature set. But for DeFi protocols in particular, you have this liquidity fragmentation, right? So DeFi protocols, many of them work better when there's more deposits in them. But when you're split across chains, you know, you're going to have deposits going into these different smart contracts on different chains. And that creates fragmentation, right? The deposits on one chain can't necessarily be used like on the protocol instance on another chain. So in general, you have this fragmentation effect that's happening that's you know, is definitely limiting in some sense, even if you are able to get to the users and assets, you know, in all these environments. So I talked before about this key unlock of general message passing or cross-chain messaging that's just come to market largely this year. There's a couple examples that like came before, but really I think a lot of the activities happened this year. You know, the Polkadot system specifically is called XCM, so that's like the way that messages are natively passed between systems on Polkadot. But as I was mentioning, there's a number of other systems, and we'll go through some examples here to give you a sense of the kinds of things that we're seeing. So I'll start first with an example of this is deployed today and in production today on Moonbeam. So Moonbeam, for context, you know, we launched in January. We're about a 6-month-old chain. There's been a lot of deployment activity, a lot of bootstrapping activity in that time, a lot of infrastructure and tools being deployed. Lido is one protocol that has deployed to Moonbeam. And so let me use this as an example of what I mean by connected contracts. So for those of you that aren't familiar, Lido is a liquid staking protocol, right? So this is a protocol that is heavily used on Ethereum mainnet, where you can take a stake position, represent it as like a liquid asset, and then use that asset that represents a stake position in other DeFi use cases. Very popular with users, right? Because they kind of get this optionality of getting staking returns, but then also being able to further deposit those assets, you know, in other places. And so the Lido team approached us some time ago, and they wanted to do a Polkadot deployment. The problem is this, right? The problem is that within the Polkadot ecosystem, DOT lives on the relay chain. The relay chain does not have any smart contract functionality on it. It only has staking functionality, governance functionality. It's a specialized chain that is acting as this kind of central hub within Polkadot. So the question was, how is the Lido team going to go about creating this like liquid staking, you know, this derivative for DOT? And so the answer is that they've created a set of smart contracts on Moonbeam. These are Solidity-based smart contracts. They're already quite familiar with the implementation of these. But we've exposed you know, functions for them, handlers, that allow them to send XCM messages from the smart contracts on Moonbeam to the Polkadot relay chain to control staking operations. Right? So now you have this permissionless system where you have smart contracts on Moonbeam that are almost, you know, doing this like remote reach out and performing these actions like on the Polkadot relay chain. But the user doesn't really know that, right? So when the user is interacting with the Lido deployment on Moonbeam for the ST.dot product, they don't realize they're interacting with two different chains. And so you know, this is a theme I'll come back to that I think there is like a key interesting thing here is that the Lido deployment on Moonbeam consists of multiple specialized chains working together to deliver a single user experience like back to the user. And so this is a, you know, first example of something that's in production now that's using a cross-chain connected approach to create, you know, a better user experience, or in this case, you know, to even create this product they want to create at all as a decentralized protocol. And so let me go to another example. So this is an example of a protocol that's under development now to be released later this year. But it also illustrates some of the concepts I've been talking about here. So the protocol is called Prime Protocol. It is I think, an over-collateralized stablecoin. So think of something like Maker. But they're taking this cross-chain connected approach. So what does that mean? So what that means is that on Moonbeam, they have kind of their brain, or this kind of hub set of contracts. And then on many other chains, they have what I call a remote branch, or kind of a satellite deployment of contracts on Avalanche, Ethereum mainnet, Polygon, and so on. And the idea is that a user can deposit collateral into their protocol on any of those chains. So let's say a user deposits collateral on Avalanche. They deposit AVAX on Avalanche. Now here's the trick. The asset does not move. There's no bridging action. There's no movement of the asset. It's locked on Avalanche, but then a message is sent back to the brain saying, this user deposited like this amount of asset on Avalanche. So now what you see is that the brain set of contracts now starts to get visibility of the deposits and credits that are happening across like all of the chains simultaneously. It has this kind of cross-chain visibility. So what that means is that same user can now go to mainnet, and they can leverage the deposit they made on Avalanche. So they can mint stablecoins on mainnet. And so this is like a key unlock here, where you have a multi-chain protocol. Users can interact with any of the chains locally, but there's cross-chain awareness in the system. So now I can leverage the deposits on one chain to do something else on another chain. I contrast it again with the current state of things right now. If you had something like Maker-like that was deployed on each chain, you would not be able to do this, right? You have an isolated market on each chain. And so this is a big unlock, and the theme from this is that I really believe that there's going to be more efficient protocols that are created that are going to be highly competitive with these older single chain style protocols using this connected contracts approach, or using this ability to connect smart contracts between chains. So I think this is a great example. Let me give another example that illustrates a different point. So we have a collaboration with a number of people, but specifically let's talk about a collaboration that's in the works with the team at Osmosis. So what they want to accomplish is, and for those of you who aren't aware, that's an app chain in the Cosmos ecosystem, heavily focused on providing great user experiences. The idea is that they want to offer users the ability to deposit DOT into this protocol. How would you do that, if you didn't have some special system? Well, users would have to, perform a bunch of bridging actions to get, that asset over to Osmosis to be able to deposit it. So their goal is to create kind of a one-click deposit experience. So how do they do that? So the way it'll work is that the user will be presented with a native DOT deposit address. They'll be able to send DOT to that address, and then what happens? Behind the scenes, we'll detect that DOT deposit. It'll get forwarded to Moonbeam as XC.dot, so that's using XCM to move the DOT onto Moonbeam, where we have what we call XC assets. Then we'll forward that XC asset to Axelar. Axelar is one of these new overlay networks. Axelar will route that asset across Axelar to Osmosis, and then on the Osmosis side, it'll get LP'd into the pool. And so the point here is that to the user, they're just getting what they kind of know and expect, a native DOT deposit address. Behind the scenes, there's this 7, 8 different steps that are happening. But the user doesn't need to know about those things. So this is the thing, this is the second big unlock in my mind around this connected contracts approach, is you can hide infrastructural complexity away from the user. Think about what the user would have to go through if they had to go through all those steps manually. There'd be 6 or 7 complicated bridging or other infrastructure steps. So now you've hidden all that away, and the user gets this very simple user experience. So to me, that's a huge win, and that's another kind of pattern of why this connected contracts approach is going to be adopted, right? It's people kind of trying to deliver superior user experiences. I'll give another example of a team we're working with at Centrifuge. So this is another Polkadot parachain. So this is an XCM example. They have a very specialized system that's specialized around creating real-world assets, tokenized versions of real-world assets. There's a lot of things that that they're quite expert in managing that process. You end up with an asset at the end, but it carries with it special requirements. So there's certain whitelists, and there's certain people that are allowed to interact with that asset. And so the idea is, in this Polkadot spirit, where if they're specialized in creating this asset, they want to access then markets and other opportunities that exist on Moonbeam. So XCM will be used to transfer that asset, but along with that will also come this idea of maintaining a set of a whitelist around this asset. right? So there's a set of like parties that are allowed to interact with this asset. So those will be honored and maintained by Moonbeam, and there'll be like a constant updating of this list via XCM. But then, users who are on that approved list will be able to, for example, deposit like into something like Moonwell, which is one of the main lending and borrowing protocols on Moonbeam. So this is a kind of a Polkadot-Native like example of the power of specializing into different like functions and being able to get a whole is greater than the sum of its parts effect. I'll give a fourth example here of Uniswap. So there is a Uniswap v3 deployment that is in flight to Moonbeam right now. One of the main motivations for this is to use a kind of a connected contracts approach to help solve some challenges that they're having, or that they're trying to address. The challenge is that as they move multi-chain, it goes back to this governance idea. So as they move multi-chain, the question is like, how is the multi-chain like kind of multiverse of Uniswap like managed from a governance perspective? They have a long-standing tradition on mainnet of governing the mainnet deployment. But what does that mean for the Moonbeam deployment, or the Polygon deployment, or these other deployments? And so the idea is that they plan to use Nomad's cross-chain messaging technology to basically consolidate all governance for their multiverse like into the mainnet like system, but then be able to affect change on any of the remote systems. So let me play an example. Let's say that there's a governance decision to change the trading fee from 0.3% to 0.25%, like the swapping fee. So in order to enact that, they can enact it locally on mainnet, but they can send like a cross-chain message now out to all of their remote deployments to also affect that change. So then there's no reliance on anyone in the middle to kind of do the will of the people, right? It's just built into the system itself that it will propagate these changes out. And so this is like a big win, right? Where there's not any confusion then around like where you go to govern the thing, or if there's multiple domains. It's very clear and simple that yes, they're deployed on many chains, but there's a single governance domain that manages the whole thing. So that's a great example, I think, of a cross-chain connected use case that's helping solve a real problem. And so, yeah, in general, I think that I've spoken about some of the themes that are coming out now. I mean, we're still early on this. There's still a lot of teams that are developing applications, but kind of the patterns and themes are starting to become clear to us. And we at Moonbeam are really trying to make a place that's optimized for these use cases. We are looking at multiple other multiple features we can build into the blockchain layer itself to help support these kinds of use cases. And so, yeah, I think we have a lot of exciting things that are in the pipeline. And I think I'll just end on this idea that I do see a lot of parallels between the evolution of how compute changed over time and blockchains. And they say that thing that things rhyme with history. They don't mirror it, but they rhyme with it. And so in compute, you had initially this kind of vision of having shared computers. So they were very expensive. So you had like a single computer, you had many people sharing it, time sharing against it, or splitting the resources. Then it moved to kind of dedicated machines, right? So maybe you had like your own, in the context, this would be your own chain, right? But longer term, it's more of this cloud idea, right? Where you have multiple different specialized services. And then as a developer, for example, you can pick and choose between these different specialized services, combine them into a single application. And so that's the long game that we see and that we're playing for, is to be a kind of connection point, to kind of be something that can help power this, let's call it something that looks like AWS, but consists of all decentralized services instead. And to be able to power this, let's call it this kind of cloud-like blockchain environment that makes it easier for developers to build, but also create scalability through the use of multiple specialized blockchains. And so, yeah, I think that's kind of what I wanted to share with you guys today. If anyone is certainly if anyone's interested in building a cross-chain connected use case, we're very interested in speaking with you. If you visit our website, there's a lot of great developer documentation and other things to help you get started. We have a number of, we have a bunch of folks from our developer relations team are here in the audience. Yeah, we'd love to hear from you. And yeah, I guess I'll see if there's any questions here at the end. All right. Thanks, everyone. Yeah, thanks.